Question number 17. A student blows across the top of a cylinder that contains water. Okay, there's a cylinder which contains water over here, and he blows air over here, which means what? When you blow here, what will happen? There will be a wave which passes like this. It gets reflected here and goes back to here like this, right? So why do we get this reflection at this point? Why do we have? Because whenever you have a denser medium, at the denser medium we assume that there is a node here in stationary waves, and at the rarer medium, that is in the medium which is being free to vibrate, okay, you have an antinode over here. Okay, we have drawn antinode and node over here. Okay, now let us read the question. A first harmonic standing wave is produced in the air of the cylinder. This is the first harmonic. What do you mean by the first harmonic? So whatever we have written is correct, which means only one quarter wave can be seen over here. Okay, so therefore now if this length is L1, I can now say L1 will be equal to lambda 1 by 4. Okay, now similarly, more water is added to the cylinder, the water level rises upwards, and as a result of it, the student blows. So the first harmonic second wave is produced with a different frequency. Okay, so you get one more wave like this. So once again, you get a node here, you get an antinode over here. This length, let it be equal to L2, and the wavelength corresponding to it will be equal to lambda 2. Here also you can write L2 is equal to lambda 2 divided by 4. Okay, you get a different frequency. What is the nature of the displacement in the air and the water surface? What is the nature of displacement here? Nature of the displacement of the air-water interface is seen to be a node here. Okay, node. So therefore, if you look at it, these two options are incorrect. These two will be correct. Okay, and the change in frequency when the water is added. What happens to the frequency? Let the frequency here be F1. Let the frequency here be F2. Now let us find out frequency F1 from here. So what we have is that from here, let me scroll this up. Okay. So from here I can now write lambda 1 is equal to 4L1, and here I can now write lambda 2 is equal to 4L2. Let us write the frequency here. Frequency F1 is equal to V by lambda 1, which should be V by 4L1 here. And what is frequency F2 here, which should be V by 4L2. I am getting the same answer. No, we are not getting, because L1 and L2 are different. See, this L1 is larger than L2. If L1 is larger than N2, what can you comment about F1 and F2? You can say F1 is lesser than F2, or you can say F2 is greater than F1, right? See, because L1 is larger, so F is inversely proportional to length. Larger the length, lesser the frequency, right? So here lesser length, see this length, do not consider this length. You need to consider the length in the air column, not in the water surface. Okay, so therefore this length is smaller, so F2 will be larger than F1 over here. So what does it mean? That means the frequencies, the new frequency that you got has increased as compared to the old frequency. Thus, which is the right one? D is the right one. Okay, let us move on to the next.